high followers. In this part you will see how to program the full project using Arduino IDE. First, you need to know that Arduino code is written in C++ with an addition of special methods and functions, which we'll mention later on. C++ is a human-readable programming language. When you create a sketch, it is processed and compiled to machine language. For those that they don't know what I mean by sketch, a sketch is a name given to Arduino code files. The Arduino Integrated Development Environment is the main text editing program used for Arduino programming. It is where you'll be typing up your code before uploading it to the board you want to program. Arduino code is referred to as sketches. As you can see, the IDE has a minimalist design. There are only 5 headings on the menu bar, as well as a series of buttons underneath which allow you to verify and upload your sketches. Essentially, the IDE translates and compiles your sketches into code that Arduino can understand. Once your Arduino code is compiled, it's then uploaded to the board's memory. If there are any errors in the Arduino code, the warning message will flag up, prompting the user to make changes. Most new users often experience difficulty with compiling because of Arduino's stringent syntax requirements. If you make any mistakes in your punctuation when using Arduino, the code won't compile and you'll be met with an error message. Now let's get started with the code. First thing, let's talk about variables declaration. You have to know that whenever you're using Arduino, you need to declare global variables and instances to be used later on. In a nutshell, a variable allows you to name and store a value to be used in the future. For example, you would store data acquired from a sensor in order to use it later. To declare a variable, you simply define its type, name and initial value. For this project, I declared 5 variables. The first one is an array to display time. I will explain the exact function for this array below. The second thing I declared is the hour, minute, second and the half second for facilitating programming and concept of a binary clock. For minute and hour, I fix a value for him as a default at beginning. I declared also 16 variables for LEDs. Every Arduino sketch must have a setup function. This function defines the initial state of the Arduino upon boot and runs only once. Here we'll define the following. Pin functionality using the pin mode function. Initial state of pins. For this project, the initial state for LEDs is as output not input like sensors, because sensors can load data to Arduino. Now for void loop. The loop function is also a must for every Arduino sketch and executes once void setup is complete. It is the main function and as its name hints, it runs in a loop over and over again. The loop describes the main logic of your circuit. For a void loop, we need 2 functions. The first is for calculating time. The status of half second is auto increment ++. It means that after completing 2 half second, the result is 1 second. If not, do not enter to if statement of seconds. If 2 half is completed, you will enter to seconds statement and will add second. The same principle for seconds and hours. If second equals to 60, add a minute, and if minute equals to 60, add an hour. And if hour equals 24, the code does a reset. And show hours equal to 0 and minutes equals to 0. It means new day. The second function is time update. It means how to time display using LEDs. The principle of displaying hours in the building using LEDs is simple but not easy to understand. For getting hours column, the code divides the hour with 10. The result is for the first column, and the rest of the division is for the second column. And for displaying minutes, the code divide minutes with 10, and the same, the result of the division is for the third column, the rest of division is for the fourth column.